Have you ever paused to wonder why a parabolic curve is so important in our daily life? This seemingly simple shape, a curve that's symmetrical and unbroken, holds more significance than you might initially think. In the realm of mathematics, curves have an intriguing tale to tell. They are not just arbitrary lines drawn on a graph. No, these are the silent storytellers of the universe, whispering the secrets of physics, geometry, and even nature itself. Among these, the parabolic curve holds a special place, a protagonist in this grand narrative. From the trajectory of a thrown baseball to the design of satellite dishes, the parabolic curve is everywhere, quietly shaping the world around us. It's a central figure in fields as diverse as architecture, physics, and engineering. Its unique properties make it an indispensable tool in these domains. Today, we embark on a journey to unravel the mystery of the parabolic curve. What exactly is a parabolic curve, you may ask? Well, let's dive right into it. A parabolic curve, or simply a parabola, is a type of curve that you might have come across quite often without even realizing it. Picture a U-shaped curve, symmetrical and smooth. That's your basic parabola. But what makes it truly interesting is its unique properties and the way it behaves. Now, to understand a parabola, we can turn to a simple everyday example. Imagine tossing a ball straight up into the air. The path that the ball follows, that's a parabolic curve. It starts at a certain point, rises to a peak, and then falls back down following the same path. This symmetry is one of the defining characteristics of a parabola. The shape of a parabola is determined by a particular mathematical relationship. For any point on the curve, the distance to a fixed point, called the focus, and the distance to a fixed line, called the directrix, are always in the same ratio. This relationship gives the parabola its distinctive U-shape. But parabolas are not just theoretical constructs, we see them in action all around us. Take for instance the design of a satellite dish. The dish is shaped like a parabola to capture signals that come in parallel to its axis and focus them to a single point, where the receiver is located. This is no accident. The properties of the parabolic shape make it perfect for this job. Parabolas also play a crucial role in the field of optics. The mirrors in headlights and flashlights are parabolic to focus light into a beam. Again, the unique properties of the parabola make this possible. So, you see, the parabolic curve is more than just a mathematical concept. It's a fundamental shape that nature and technology alike use to their advantage. It's in the path of a thrown ball, the design of a satellite dish, the mirrors of headlights, and countless other places. So, in essence, a parabolic curve is quite a unique and interesting shape, isn't it? Let's delve a little deeper into the mathematical world of parabolic curves. Parabolic curves have a distinct and beautiful symmetry. This symmetry is not just pleasing to the eye, but it also has important mathematical properties. A parabola is defined as the set of all points in a plane that are equidistant from a fixed point, known as the focus, and a fixed line, known as the directrix. This might sound a bit complicated, but it's actually quite simple when you break it down. Imagine a point and a line. The points that are the same distance from both the point and the line form a parabolic curve. The vertex of the parabola is the point on the curve that is closest to the directrix. But where things get even more interesting is when we look at parabolas in terms of quadratic functions. A quadratic function is a mathematical function that can be described by an equation of the form y equals sine x2 plus bx plus c, where a, b, and c are constants and x is the variable. The graph of a quadratic function is a parabola. If a is positive, the parabola opens upwards, and its vertex is the minimum point. If a is negative, the parabola opens downwards, and its vertex is the maximum point. The line of symmetry of a parabola is a vertical line that passes through the vertex, and it divides the parabola into two mirror images. Parabolas also have a property known as directrix property. This states that any point on the parabola is closer to the focus than to the directrix. This property is what makes parabolic curves so important in optics and satellite dishes, but we'll get to that later. For now, let's just marvel at the elegance of these curves, their symmetry, their simple yet powerful mathematical definition. Whether it's in the realm of abstract mathematics or the physical world around us, parabolic curves have a fascinating role to play. That's the beauty of mathematics. It's all around us, even in the form of a parabolic curve. Now that we've seen what a parabolic curve is, where exactly do we see it in our daily life? Let's start with architecture. The magnificent arches that stand strong in many iconic buildings, bridges, and monuments around the world are often shaped as parabolic curves. The unique properties of these curves, including their strength and stability, make them an ideal choice for architects. Switching gears to sports, the trajectory of a football thrown by a quarterback or a basketball shot by a player or even a golf ball struck by a golfer all follow a parabolic curve. This is due to the forces of gravity and air resistance acting on the ball. Understanding the properties of this curve can significantly improve a player's performance. Moving on to another fascinating realm, let's talk about parabolic curves in nature. The flight paths of many birds and insects often resemble parabolic curves. Even the path of a dolphin leaping out and back into the water follows a similar pattern. These creatures have intuitively mastered the art of moving in parabolic paths to conserve energy and optimize their travel. Now, switch on your headlights or flashlights in the dark, and you'll see another example of a parabolic curve. The reflector at the back of these lights is shaped as a parabola. This shape ensures that light rays emitted by the bulb are reflected outwards in parallel lines, providing a well-focused beam of light. Have you ever used a satellite dish or seen a large radio telescope? These devices have parabolic shapes that help collect signals from far-off places and focus them at a single point, the receiver, enabling us to watch our favorite channels or observe distant galaxies. Even in the world of finance, parabolic curves are present. The price of a stock or commodity in a market often follows a parabolic curve during periods of rapid growth or decline. Fascinating, isn't it? How something as abstract as a parabolic curve finds its way into our everyday life. So, we've seen how prevalent parabolic curves are, but why are they so important? Well, let's delve into the world of physics first. Parabolic curves are at the heart of projectile motion. Picture a football being kicked, a stone being skipped across a lake, or an arrow being shot from a bow. All these objects follow a parabolic path due to the force of gravity and the initial velocity. This parabolic pattern allows us to predict the trajectory of these objects with great precision. Shifting gears to engineering, the power of parabolic curves is equally profound. One of the most prominent examples is in the design of bridges. The parabolic arch in bridges evenly distributes the weight of the bridge and its load to the supports, ensuring strength and stability. It's the reason why many of the world's longest and most durable bridges boast a parabolic design. But it doesn't stop there. The parabolic curve also plays a crucial role in the field of technology. Satellites' dish antennas, for example, are shaped in a parabola to capture and focus signals at a single point, ensuring clear and effective communication. Similarly, in the realm of optics, parabolic mirrors are used in telescopes, microscopes, and headlights to focus light rays into a single point, providing clear and concentrated visibility. Moreover, parabolic curves have a significant role in the world of economics. The curve is used in quadratic functions to model and predict various economic phenomena, including supply and demand, profit maximization, and market equilibrium. From physics to engineering, technology to economics, the parabolic curve is a mathematical marvel, with practical applications that are as diverse as they are important. It's a testament to the beauty and utility of mathematics in shaping our understanding of the world and enhancing our ability to navigate it. The power of the parabolic curve is truly remarkable, shaping the world in ways we often take for granted. As we wrap up, let's appreciate the beauty and complexity of the parabolic curve. This unassuming U-shaped curve is so much more than meets the eye. It's a testament to the harmony that exists between mathematics and our everyday lives. From the trajectory of a basketball shot to the design of satellite dishes and car headlights, the parabolic curve makes its presence known. We've seen how this curve plays a pivotal role in mathematics. It's the graph of a quadratic equation, revealing a world of symmetrical beauty and practical applications. Parabolic curves don't just exist in textbooks, they're in our architecture, our sports, and our technological advancements. The power of the parabolic curve is undeniable. It's a testament to the surprising, yet elegant ways in which math permeates our world. Next time you spot a parabolic curve, remember, it's not just a curve, it's a mathematical marvel that shapes our world.